Understand sign convention today for the chapter light. Okay, so this is applicable for both 10th standard and 12th standard. So 12th standard we would call it as ray optics. 10th standard the chapter name is light. Okay, so it's a very basic concept. Instead of memorizing 100 tricks, okay, all over YouTube you have so many tricks and so many short forms what they are teaching. It's better to understand the logic behind it. Okay, so how the sign convention is actually decided. Okay, so you understand the logic behind, so you won't forget it and you will be able to apply it for any special cases also. Special cases we will discuss in the end. Okay, so first let us take the first basic thing, which is a, let us say, convex mirror. Okay, so what I'm going to do is, let us say I have a convex mirror, and here, so convex mirror, I can shade this side, I can draw it like this, or I can also draw it in this way, isn't it? So I have to shade this side. It is not compulsory that the mirror must be only towards the left or only towards the right, not like that. Okay, it's just a simple what do you call, simple rule that teachers tell you in order to avoid confusion. But it is not wrong to place the mirror in the right side or the left side or whatever side it is. Okay, so first let us say in both cases I will teach you how to find the sign convention. Okay, so what happens is, let us say this is the principal axis, and where will you place the object now? So object will be placed in the side where the shining surface is present, isn't it? So you can't see anything if on the rough surface, only from the shining surface you can see the image, isn't it? So you will place the object here, and in this case you will place the object here. Am I correct? Now when the object is placed here, what happens? Light will travel in all directions from the object, isn't it? But we have to select the direction which is towards the mirror. Okay, so which direction is towards the mirror? So this is the direction of light towards the mirror. Direction of light which is towards the mirror. Same way here, light will come in all directions, but we have to take the direction of light towards the mirror. So this is the direction of light. This is a very important step. So once we fix the direction of light, okay, then the remaining just flows. Okay, so what happens? Now based on the direction of light, you have to measure the distances. Okay, how to measure the distance? From where will you start measuring the distance? Always you have to start from the optical instrument. What is an optical instrument? An optical instrument is a mirror or a lens. Okay, so all these are optical instruments. Which one is the optical instrument here? The convex mirror. So let us say this is the point from where you have to start the measurement. Okay, let us say I want to measure the object distance. Object distance means distance between object and the optical instrument is the object distance. From where should I start it? From the optical instrument. So when I go from here to the object, I will be traveling in the opposite direction of light, isn't it? So the distance is opposite. So what does it tell me? It tells us that the object distance is negative. Object distance is negative. Do you understand? Same thing we can apply here. It doesn't matter whether you are in the right side or left side. So don't remember based on right and left. Okay, so it can be any direction. Whatever direction it is, understand the logic behind. Okay, so here we are going to measure from the instrument. Okay, you are going towards the object. So here you can see this is opposite to the direction of light. Therefore, the object distance u will be negative. Okay, so u will be negative. So you can see here object is negative. Now let us apply this concept in any other type of mirror. So let us say I have a concave mirror. Okay, so what happens in a concave mirror? Where will I place the object? So I'll place the object here. So towards the instrument I have to take the direction of light. I will fix it. Direction of light is fixed. Now I have to measure from here towards the object. So u will be taken as what, ma? Negative. Okay, suppose I place the concave mirror in this way. Okay, I place the concave mirror like this. This is the principal axis. Where will I place the object? The object will be now placed this side, isn't it? So where is the direction of light? So this is the direction of light. And how will you measure it? You have to measure from the instrument towards the object. So you can see here once again u will be negative. So whenever the direction of light and the measuring distance is opposite, then your measurement will be taken as negative. Okay. Now there are some cases where we have positive u. Okay, so this is for your 12th standard. In 10th standard mostly you won't get anything as positive u. Okay, so we call this type of negative u, we call, here you are placing a real object. Okay, what is this? Real object means an object is truly placed in front of the mirror, so it is a real object. Okay, now there is something called as virtual object. What is a virtual object? A virtual object is which is not present in reality. For example, if you go to a changing room, okay, a dressing room, you can see multiple images of your self is formed because of multiple mirrors, isn't it? So how does the image form there? When a person is standing, his image is formed in one mirror. The image in the first mirror acts as the object for the second mirror. The image in the second mirror acts as the object for the third mirror, and so on. Okay, so like this what happens, multiple images are formed. So there the object, only one object is real, but the other objects that are there are virtual, which means inside the mirror. Okay, so when we have a virtual object, let us say you have a convex mirror, virtual object is supposed to be taken, okay, like this. Let us say virtual object comes from converging rays. Okay, so the object is supposed to be coming from here. So what happens? Okay, now the direction of light is this side. Direction of light is this side. Now since these two lines are appearing to meet here, okay, this is your virtual object. What is this point? This is your virtual object. So what happens is the object is behind the mirror. It is not present in reality, but it is behind the mirror. Now when you measure the distance, what happens? You are going to go from the instrument towards the measuring point, and you can see the direction of light is same, which means here u will be positive. Okay, u will be positive. So this concept you have to apply for only what objects, ma? Virtual objects. So whenever you have virtual objects, you will get u as positive, and when you have real objects, you have u as negative. This is the simple idea. So this is about object. Now let us measure other distances. Okay, so for example, I have a mirror and an object here. Okay, so always you need an object to identify the direction of light. Okay, so direction of light is this side. Let us say an image is formed here. Okay, I'm forming an image behind the mirror. This is the image and this is the object. So what will happen? I want to measure the image distance. So from where will I start? I will start from the mirror towards the image. So this is same as direction of light. So what is V here? V will be positive. Okay. If I want to measure the object distance, what will be U here? U will be negative. Why? Because this is opposite to the direction of light. Okay. Now I can form a concave. I can take a concave mirror. I can take an object. So what is this? This is the direction of light. See how I am marking the direction of light. Direction of light should always be towards the mirror. Okay. So from the mirror, you want to measure the image. Okay. So let us say the image is formed here. So how will I measure the image distance? Opposite to the direction of light. So what is V in this case? Negative. U is also negative. Suppose I get a virtual object. Okay. So for example, I am getting a virtual object. Virtual image. So what will happen if there is a virtual image? So you are going to take in the same direction. So what will happen? The direction of light and the distance measured is same. So here the V will be positive. Okay. So it depends where the image is formed. So if the image is formed opposite to the direction of light, it will be negative. Same as the direction of light, it will be positive. And same applies for lenses also. So in lenses also you can see here you have an object this side. This will be the direction of light. So first when the light falls on this surface, okay, it falls on this surface, where will you take the radius of curvature? So if the curvature is like this, the radius of curvature is obviously going to be this side. and the focal length of the first surface will be this side. Am I correct? Now I want to measure the focal length. So from where will I start? I will start from the instrument towards the focus. So they both are in the same direction. What does it tell me about the focal length? The focal length will be positive. Okay. Now, ma'am, if I place the object on the right side, what will happen? So suppose I place the object on the right side. Let us say which is the first surface on which it is falling. You have to consider the first surface. Okay, so this is the direction of light. Direction of light. And you can see the curvature is towards the left, and let us say this is the focus f2. So from the instrument I will be measuring towards f2. You can see the direction of light and f2 are in the same direction, so f2 is once again positive. So it does not matter whether we are placing the image object in the left or the right. You can place anywhere. Okay, the focal length of a convex lens is always going to be positive, and you know now why it is positive. Okay, so you can place it on the left or on the right, it doesn't matter. Always you have to consider the direction of light and the direction of the measurement that you are taking, and always start the measurement from the instrument. Okay, so here the instrument is lens. It can also be a mirror in some cases, depends. Okay, now let us take a concave lens. Okay, so concave lens, what happens? First let us discuss the convex mirror. Okay, so for the focal length of the convex mirror, what happens? Once again, you are placing the object this side. This is the direction of light. Okay, which side is the curved surface? This side, no? So obviously the radius is going to be here. The focal length is going to be this side. So I want to measure the focal length. Okay, so I will be measuring in the same direction. So same direction means what? Focal length has to be positive. So whenever there is a convex mirror or a convex lens, you can see that the focal length is always positive. Okay, now let us say I have a concave lens. Okay, and I place the object this side. Which is the first surface? This is the first surface on which the light will fall. So this is the direction of light. Direction of light. Okay, and how will we measure it? From the instrument. So this is the curved surface. I will have the focus on the left for the first curved surface f1. Okay, so how am I going to measure it? Opposite to the direction of light. So f1 is going to be negative. F1 is going to be negative. Understood, children? Let us take a concave mirror. Okay, so in the concave mirror also you can place the object this side. So this will be the direction of light. Okay, and how will I measure it? So this side is the curved surface, no? It is facing towards the left, so focal length will be somewhere here. So I have to measure it opposite to the direction of light. So here you can see focal length is negative. So you can see how for a concave mirror and a concave lens you are getting negative focal length. Okay, so there is no need to memorize this. Just understand the sign convention. If it is same direction of light positive, opposite direction of light negative. As simple as that. Is it clear, children? If you have any doubts, you can comment. I'll clear your doubts right away. Thank you.